Okay, boys and girls, you can't really see much here or there, but what I had to do was cut the power down to the motor so I could see what the hell is going on. So it's getting hardly any power. But as you can see, it's puffing and braking, right? It's puffing and braking. And it's doing it based on the pulses of our triggers, based on the placement of this and the fact that I'm going screaming down here because I still have a voltage loss. Even at 15 volts, I'm only getting like 9. So if I slow this down, I'm in idle mode. That's idle mode. Now these lights are still going because that's all still going. The switch is done in the relay. It's switching from the blue line to the yellow line, feeding that to the motor. So that's idle. And there's the puff and chuff. That's what the puff and chuff will look like. But I have to turn up the power in order to get the motor. But what I'm going to do now is I'm going to build a smoke. I got a smoke over there. I'm going to put it together and put it on here so that we can see what the pulses do to smoke. And if that works, if it works, I don't know. Here we are. We have a working system. I'm very happy. I'm very proud. I didn't know if it was in there. I don't know how or what. I bypassed a lot of stuff. I'll have to talk to Robert on what we can keep or not keep. But the trick is I got to get a lower power regulator, and that'll ease a lot of the pain on this stuff. Then we're going to have to understand the pulsing of the brake and the puff. We may need a longer pulse for the brake, and I don't know if there's a way to do that or not, or a shorter pulse for the puff. I don't know if there's a way to do that or not. So that's where we are. But I can safely say we have a system that gives us puff, brake, and idle. Yes. And it wasn't that bad. It was just bad. It was just learning the limitations of my inputs, that this guy requires more volts than I normally feed anything on a train, right? 12 volts. Unless you're turning the motor, you don't do that to components. This one needs it. So I'm going to get a smaller piece, and that'll rectify that. But the added piece was getting the sensors to work and realizing I had too many. I had it for the the other sensors, you know, whatever they are, Hall effect switches. But the Hall effect setups that I have only sends you out a pulse that is good for digital, and this is not a digital thing. This, not in that way anyway. It wasn't ready for that. So I had to get something that was more of an analog output that we could use. So I had to go away from that to the old reed switch with a magnet. The magnets work. The reed switches are working. I couldn't be happier. I mean, it may not be the end result. We're still going to refine everything that we have here, but we now have the concept functioning and showing us the pulse on the fan. For me, that's good. That's real good. And we know we have the idle. We saw the idle. So tune the idle down so it's a whiff at the thing. You're saving power. You're saving smoke. Get this thing so it's puff and chuff. And as you speed up and slow down. Now, if we were going slower, I would think that might work. But I could not go slower and maintain the solenoid trigger because of the loss of signal, loss of power coming in through this particular sensor. It's a very inefficient switch, I have to say. And I was warned of that. That's why I hadn't used it very much. It requires a lot of energy. It loses a lot of energy as it completes its circuit. If there was a different way of doing the relay, like a pass-through or something like that, we might have a way of doing it. But the end result's going to be, I'm going to get a smaller relay. That is going to be a non-issue. And then we're going to have low-speed fan, and I can rev it up and bring it down. And I can tune, I'm hoping, tune the fan speed to get what I need. Then if it's still not right, I'm going to have to look into these circuits and see if I can add resistance or capacitance in some place and store a little energy or bleed off a little energy somewhere. But I think that's where we're at. Oh my God. Oh, and adding the indicator lights for me, that was monumental. I had to have them. I needed to know what was going on and where and when and how. And I was doing probes, but you can't see it. You can read a meter, but you can't. So this way, I've got all three power outputs: the main to the motor, uh, puff and brake, and I knew the trigger was on. If it's on, it's on. That's a given. So I didn't really put a trigger for a switch for that, but I do have another light I found, so I can put lights where I want them, and I still may do that as we go along, so I'll know what's happening. Okay, that's a pleasant wrap. And it's 5:30 on the nut. Look at that. Well, okay, I'm a little late, but my clock's fast. I remembered now, my clock's fast. So good day, a very good day. Finally, after slugging it out, I think we're in good shape. I think we're gonna have buffalo chicken pizza tonight too, which is always a treat. And I've already called up, get the Bailey's glasses out. By God, we are celebrating. Oh, so fun. Finally got it. And Robert was on and I was not. Now I am. And oh boy. This ought to be fun. From now on, it's going to be fun. I can say that. We've got it. We know what it can and can't do, and we can replicate it. Now we got to work on, sensors, timing, the right relay. There's the call. Okay, gang. On my way. There we go. I hope you enjoyed this. I'm sorry for the start and stop and messing around on a moaning. Oh, Lordy, I was moaning. But I'm not now. I'm thrilled. I'm happy. Okay, we're out of here. Have a good day. Have a good night. And tomorrow is another day. And by golly, we're just going to chug through this week. I just know it. We're going to chug through it. Okay, later. Bye.